Ladies and gentlemen, both here at the Hexagon Manufacturing Intelligence showroom and via ITAP Connected, welcome and thank you for joining us on day 3 of the 3rd edition of Industrial Transformation Asia Pacific, a Hanover Messe event. This year's edition has seen over 7,000 registered attendees from more over 6 countries around the world, all made possible through this first hybrid experience that this year's platform brings. And we are making history today with the very first hybrid edition of ITAP in a new business events environment. This may be a new format for Industrial Transformation Asia Pacific, but we believe that with the spirit of learning, networking, and collaboration, you live with valuable takeaways, new connections, and the same immersive experience. If not more, as the conversation continues on ITAP Connected beyond these 3 days. So it's my pleasure to be moderator for this session, Connected Workflow with Hexagon Solutions. First of all, may I briefly introduce our panelists for today. Mr. Vada, Sales Director, Design and Engineering. Mr. Amit Lele, Head of Sales, Asian Production Software. And Mr. KK Goh, Director, Manufacturing and Production Business Unit. And myself here, I'm the Country Manager. So we are all concerned about smart factory. I believe that technology has changed. This involves the integration of the physical and software in production. Industry transformation is coming fast. And to complete in tomorrow's world and beyond, our customers are realizing the need for organization transformation, flexible production, and digital transformation. So the question is, are you ready for Industry 4.0? And what challenges you face in the near future? So let's take a look here. So Mr. Vada, in your opinion, what is the role of simulation in industrial transformation?
Oh, thank you. Excellent question. So when we visit our customers and visit their shop floors, we see them, they spend so much of time and efforts in doing trial and error methods to make the manufacturing process and their process parameters correct. This includes stamping, bulk metal forming, rolling, forging, welding, even painting process. So that takes a lot of time, money, and effort to make these things correct. And even then, many customers, they cannot make those things correct. So simulation helps to do all these things digitally, virtually in a computer, study everything, optimize everything even before a physical tryout. Let me example with respect to a simple example. So, example, this is a connecting rod. We have a connecting rod with, this connecting rod goes through 7 different steps before a part is being manufactured, connecting rod is being manufactured. So, this is the first step. This is the first step. Yeah. So this is the first step where we have the bar stock coming up, and there is a heating. First step involves, second step involves heating and also roll forming process. What you can see on the left hand side is the simulation, and the right side is actually the physical one. Here the bar gets heated up, and you can see that on the right hand side is being heated up, but on the simulation side you can see that not only you can see the bar getting heated up, but also you can see the internal of it, how the temperature distribution happens. The next step involves the rolling process. Okay, this is an intermediate step process. You can see that on the rolling process on the simulation, not only you can see exactly what you do on the simulation, but also you can see the plastic strains. That is the intelligence behind what happens inside this particular part happens. The next step involves is the hot forging process. This goes through 3 or 4 steps process. Okay, you can see that on the right hand side, it is being hammered, and you can see that the same hammering happens on the simulation side. You can see both of them happening in parallel. And whatever the number of steps, 3 or 4 steps, you can really do this on the simulation side. The next step involves the finishing of the process, okay? The flash removal and the finishing of the process. At this intermediate step, it stands there, then you get the hit, and also the flash is being removed, and the final finishing happens. But what you see here inside is not only you are able to perfect the process, but also you get the internals of what is happening. After the part is manufactured, if there is going to be any failure, anything happens, you can see in the simulation process. So in short, simulation helps to digitally transform what you do physically into a manufacturing virtually. Thereby you gain time, you save the cost, and also optimize the parameters. Flash is a very important thing for all those people. If you can reduce the amount of splash, it directly involves the money, okay? So that way, Hexagon MSc software is in a position to do a digital transformation of what is being done physically into a virtual way. Thank you.
Yeah. This is great, yeah. But could you elaborate in details, the technologies from Hexagon?
Yes. So Hexagon has gone from this kind of a simulation into what we call as a multiphysics co-simulation. Let me explain with respect to another example. What we call as a crash box. Okay, in this, crash box is usually in crash conditions. These are all these components which absorb a lot of energy, the energy on the crash, so that it can save people, it can save critical components. So Hexagon has got this welding simulation software. We can simulate various types of welding. So this is the bar. Then this is being welded on this base plate, where we can understand and optimize the welding strategy, fixing strategy, the way you do the welding, different types of welding. After that, what happens? This goes into a actual simulation process. There are 2 types of simulation is done. With history means after the welding is done, it generates so much of heating, and during cooling process, there are so much of internal energy or internal forces are being captured. If it is not counted for the next simulation, what we call as the implicit crash simulation, the results are wrong. See here, this is with the history. You can see the way it is failing, and without the history, okay, here there is no welding effect included. It is different, and also the amount of failure happens ahead with history is different. So that way, Hexagon MSc software is in a position to get the simulation right at the first time in a correct way. Thank you so much.
Right. Thank you, Mr. Wada. Right. So Amit, the questions from the customers today is also about, designing, So in your opinion, what exactly means smart concept to reality?
Yeah, thank you, Sia. And smart concept to reality is an important part of Hexagon connected workflow. As we know, for Hexagon, our motto is quality drives productivity. So manufacturing companies can actually enhance the productivity by ensuring the quality at every stage of product life cycle by using Hexagon solutions, for instance. We actually help our customers and manufacturing companies to collect and analyze the digital data in the digital world, and also help them convert it into a meaningful, actionable output to be implemented in the real world, through various Hexagon solutions. And the best part here is the entire suite of solutions are interconnected with analytics, with various platforms like SFX and Exalt from Hexagon. Coming back to the question which you just now raised, is smart concept to reality has, this is how we can explain. Basically, it starts with a sketch or a physical part which needs to be converted into a CAD model. CAD model is converted into a CAM programming. CAM program is converted into a relevant NC program which is valid for that particular CNC machine or controller. Then it is validated, optimized, and simulated in another solution from Hexagon before the actual manufacturing of that part takes place. So this is a kind of brief explanation of the concept to reality from Hexagon. And as we have seen, we have demonstrated this particular part here called mask holder, which has become very prominent in recent times because of the pandemic. And this is the process which we have been able to follow to, from concept to reality for mask holder. So you'll be surprised to know that we did not have a CAD model for this particular part. So we basically we reverse engineered this part by using Hexagon Absolute ARM and also Visi Reverse software. Then the CAD model was converted into a CAM program. Before that, there is a mold design which takes place in terms of optimizing, adding some accessories for the mold. Then the Visi flow is used to basically simulate to check any probable defects in manufacturing before the injection molding takes place, like warpage, like air traps, like weld lines, for instance. And then once the optimized mold and accessories is ready, then it is basically converted into a CAM program by using Visi CAM module from Hexagon. And then, of course, once we have the G code, which is valid for a relevant machine, is checked with a solution called NC Simule, which is basically validated for the G code. It is simulated for any kind of possible accidents or interference, and then it is also optimized in terms of the cycle time and the tool paths overall. And the best part here is everything is done digitally in the digital world before the manufacturing companies actually start manufacturing the physical part on the machine. And Work Explorer here, which is basically a collaborative 3D viewer, helps all the functions, all the departments and in a manufacturing company to access the CAD model without really spending a fortune on a classic CAD kind of solution. So this is in brief, the smart concept to reality fundamentals in Hexagon connected workflow. Thank you.
Thank you again, Amik. Thank you for a very detailed explanation about smart concept to reality. So here's a question for you, KK. We know that Hexagon have introduced many new exciting technologies today, and one of them is actually asset management. So in your opinion, can you tell us a little more about what is this SFX asset management tool?
Yes, thank you, Sia. Let me just briefly explain that we all understand that data is the new gold, it is the oil. So SFX asset management was designed with the concept of getting data from end-to-end solutions. That's to say, from your production software, from your production, from your process, from your design, from your quality inspection, how do we link them together? As you can see over here on the screen, itself basically explains that we are able to connect all your processes and manage them from end to end. And that itself is important because it helps you to increase speed, because you get to know information fast enough. It helps you to maintain your quality at every stage, because once you have data, you're able to act timely and accurately at the right place. And of course, with that, you will save costs because you reduce your scraps, because you're able to take decision at the right time, at the fastest time. That itself will help you to compete well as a manufacturer, because we can't be always going about lowering costs and cost itself, but basically we are looking at ways to optimize your process. So SFX, asset management, is designed in this concept to link all your processes, all your machines together to give you the ultimate information, so you can optimize your processes.
Yeah. On that aspect, we understood, Hexagon is right in the forefront of Industrial 4.0 implementation, and our customers talk about smart factory or smart automation. Again, in your opinion, why do you think smart production with closed loop is very important?
Yeah, I think most of you have experienced my explanation of closed loop feedback capability. I think that itself is important, because the moment we are able to harness your parameters around your environment, your machine, your tool usage, and also your quality inspected results from your products, you're able to make autonomous decision to make sure your machine can do the auto feedback. So for us, Hexagon, we have these solutions, what we call QDAS. In fact, this evening at 8 p.m., there will be an official launch of this product. It allows you to make intelligence decision by linking up your CNC machines with inspection equipment and allow you to make this autonomous to offset capability by taking in, like say, environment parameters, temperature, humidity, machine parameter, to feed rate, spindle speed, and also measured parameters. In this case, you can actually correlate them and make intelligent decision when to inspect, where to inspect, when to come in to intervene, and when to improve your processes so that you get the optimum result. So our whole entire idea is to put quality at every stage of your process. In your design, simulate before you manufacture. When you program, simulate before you go to the shop floor. When you produce, at every stage you measure and intervene at the right time so that you do not make mistake at the end stage. I can also just briefly share two of the possibilities, what we say a tempo, that means automation, allow you to have 24/7 kind of operation, lights out operation, and even defects detection cell that allow you to quickly detect defect 24/7. All these are very good examples of how you can have this closed loop feedback back to your machine, back to your design, back to your production shop floor to make sure everything is A-OK. Thank you.
Okay, thank you very much for this very interesting talk. So I'd like to now move to some questions from the audience here. So maybe I'd like to start with one question coming from our digital audience. So here's a question, maybe I think it's directed at you, Vada, to yourself, you know. So the question is, what's your experience with application of smart design and smart engineering in Asian countries, you know? How do they differ across the board? Yeah.
Okay, thank you for that question. Across ASEAN, we see that there are two types of users. One for those people who use this design and engineering for R&D to improve their products. Then there is another set of users who use this software to improve their manufacturing processes. So we see that, you know, two different things depending upon the way the ASEAN countries are. For example, in Singapore, we see that a lot of R&D related works happen, but we go to a place like Thailand, Vietnam, where there are more of suppliers and there are a lot of automotive companies. There we see that the manufacturing related companies, even we have customers who make for bolt and bolt to manufacture the bolt. Okay, you may think the bolt is very simple, but that really goes through 6 different processes. They make a lot of money by, you know, simplifying the process, maybe consolidating these processes. Yep. So today we see that this digital transformation of taking out the physical tryout by a virtual simulation is gaining popular. Even before this COVID situation, we saw that it is already there. But, you know, with the current COVID and beyond COVID, we see that the adaptation of doing a physical to virtual will move up very, very fast. Thank you.
Okay, thank you, Wada. Yeah, thank you very much. Another questions here. Again, from one of our customer here. I think it's very interesting also for you, KK. I think the question will be, you know, can Hexagon share any success stories of closed feedback loop, the tool?
Yeah, I'd like to share a few companies that have successfully implemented this closed loop feedback. Typically, they are either in the automotive or in the aerospace industry. So what happened is that one of our customers that produce a lot of impeller mainly for turbochargers for aerospace sector, they have implemented this in a small way. They have roughly about 100 plus CNC machines in the shop floor, but because they are fearful to make the big step, they actually trial on 30 machines first to see how this closed loop feedback allows them to gain productivity. And when they did that, and within less than 2 months of machine learning, AI, and implementing that, they could immediately see the benefit. And in fact, the investment within, like say, less than 6 months have got the investment back, and within 1 year, they have actually saved millions of dollars. So, and now they are going to phase 2 of implementing the remaining 70 machines in their shop floor. So, like I say, typically there are a lot of good examples. A lot of solutions are implemented in tier 1, tier 2, or even major OEMs to allow them to have this closed loop inspection, production, design kind of solutions. So those are really very good examples. Not just in Europe, US, but also in Asia Pac, in Southeast Asia, we have a few very good examples already good progress on that. Thank you.
Okay, we're just about to come to the end of this live session here. Thank you again, panelists, for this very interesting talk. So I guess maybe I'd like to, back to, Vara, what would be the one key takeaway you have for our audience here?
The thing is, move from physical to virtual, gain time, gain money, and gain competitive advantage. Thank you.
All right, thank you. I think that's right to the point.
Yep.
That's good. And what about yourself, Amit? In your opinion, what would be the one key takeaway you want to actually let our audience know?
Yeah, the digitalization is the real. It's no more just a term, and we are all prepared to partner with all the manufacturing companies to be with you, along with you in this journey. Let's do it together. Let's reach the destination of digitalization together in this. So that will be my one takeaway from this.
Okay, thank you again, Amit. Yeah, so maybe also to you, KK.
Yeah, my one takeaway is embrace technologies. Think big, start small, and then so that you can scale fast once you see the result. Embrace it.
Okay. Thank you again to our physical guests here. Thank you for your participation. So I hope you have enjoyed the program. So thank you very much. So I thank you again to the panelists. Take care, and then goodbye.
Thank you.
Thank you.